Hi, my name is Dennis from Kitosim, and today we are going to speak about energy efficiency for buildings. As you may know, 30% of the global energy production is dedicated for heating and air conditioning our buildings, offices, industrial buildings and households. From one side, this is generating huge cost for the users of the building in terms of bill for heating and air conditioning, but from the other side we have huge CO2 footprint on our environment because of this energy production. Construction companies and architects are fully aware of this fact, and that is why they are putting efforts to calculate the energy efficiency of their future buildings. Unfortunately, they are using empirical dependencies and formulas which are accurate for typical buildings or class of buildings. For very custom designed buildings, these formulas and approaches may be inaccurate. That is why today I'm going to demonstrate you how computer simulations can be used to calculate and to optimize energy efficiency for a building. In today's video, we prepared for you one example to show you how computer simulations work. In this example, we are investigating how the different construction or building blocks are influencing our thermal behavior of our premises. In our example, we have two rooms, 10 square meters each, fully surrounded by walls. The difference here will be that one of the room is made of larger brick and the other with smaller brick. In this situation, we are going to investigate how fast each of these rooms will cool down from 10 degrees to 0 degrees. After that, we are going to conclude each of these two building blocks are more efficient. Stay with us to see the details. The construction companies are aware that if they are using smaller building blocks, that will result in longer time for construction and higher cost for labor. That is why they prefer to use larger blocks. Today, we are going to check if the larger block has disadvantages over the smaller building block. Before going into that direction, we first have to understand how the simulation works. In the nature, we have three main ways how to transfer heat. One is conduction, the other is convection, and the third is radiation. The radiation is the property of high temperature materials to emit heat. The convection is the property warmer fluid to go up and colder fluid to go down. And the conduction is the natural property of the material to conduct heat. In our simulation, all of these three are taken into account. In our comparison today, we are going to have two rooms which are 10 square meters of area each, 2.5 meters height and surrounded by walls. The only difference here is the construction block, where in this case is a small block, and here we have larger blocks. On top and bottom we have two concrete plates which are the same for both variants. As we mentioned, we included all the three types of heat transfer in our simulation. That is why we had to create these walls of very detailed construction blocks. In that way, the air can move freely within the building block empty spaces. In our simulation, we have the following setup. 10 degrees is starting temperature, cooling down to 0 degrees in 6 hours. As can be seen on the picture here, the starting point is 10 degrees for all of the parts inside of the simulation. That includes the concrete plates and the bricks. After 1 hour, it can be seen that some of the temperature from the inside already dropped. The outside is 0 degrees now, and the temperature started to escape from the top where the laws of natural convection start to work. Of course, within this simulation also conduction of the bricks is included and radiation, but since the temperature is very low, radiation is almost neglected. After 3 hours, after 6 hours, the temperature continues to drop, and at the 6th hour it's now 7 degrees. Let's see how we compare these results to the larger construction block results. The temperature after 6 hours is the same. The conclusions out of this simulation is that the larger block has advantages over the smaller block, because in thermal point of view they behave very similar, but in terms of construction, time and labor cost, the larger block will have better performance. So if you have to choose the bricks for your next project, it is better for you to use the largest possible construction block. This will give you the thermal advantages combined with optimized time for construction and lower labor cost.